Morning Year 10, we're going to be looking at scatter graphs, scatter diagrams today. Start your activity to set you on your way. It's about percentages, a little bit of revision. Work out the percentage changes. £35 up by 40%, £39 down by 70%. Probably going to need a calculator to do some of these calculations. Calculate the percentage change. You've gone from 146 up to 345. What's the percentage increase or decrease? So the difference between those two numbers as a proportion of what you started with. Similarly, 585 to 496, has it gone up, has it gone down? The difference between those two numbers as a proportion of the original number, what is your percentage increase or decrease? Last problem, it's about compound interest. £12,600 paid for a car by Tom. It's going down, depreciating in value by 17.5% each year. So, okay, it's going down in value by that amount each year. Okay, feel free to turn the presentation off while you have a go at those. You will need a calculator to do certainly the later calculations there. Good luck with that, and when you switch back on again, I'll go through the solutions for you. Okay, so the solutions. £35 up by 40%. This one we could sort of do without a calculator. 10% of £35 is going to be £3.50. 4 lots of £3.50 is £14. £14 onto your £35 gives us £49 in total. Your increase is going up to £49. Decrease, £39 by 70%. 10% is going to be £3.90. 7 lots of that, take that away from your £39 and it gives you £11.70 as your solution. What's the difference between these two numbers? Take the difference of between those two numbers as a proportion. So it's going to be a top-heavy fraction of your 146 original. It is an increase, it's going up in value, 136%. Difference between the two numbers, it's going down, so it's going to be a decrease. Difference between the two numbers as a proportion of your 585, 15% decrease. Tom buying a car for 12,600. Depreciating in value by 17.5%. If it was going up by 17.5% each year, your multiplier would be this, 1.175. But it's going down in value each year. So your multiplier is going to be that 0.175 taken away from 1. So that is going to be your multiplier. So for the first part of the calculation for 6 years, you're going to have your 12,600 starting figure. Use your multiplier. You use that multiplier 6 times, so you're raising it to the power of 6. And that gives you your solution, 3,973. Similarly, over 10 years, start off with your 12,600, multiply by your multiplier, this time raised to the power of 10, and that gives you your solution of 1,840. Cars, not a particularly good investment. So that's your starter activity concluded and completed. On to the main part of the lesson. Scatter diagrams, scatter graphs. Being able to draw one for yourself, being able to draw a scatter diagram, taking some raw data. Can you draw a line of best fit? These are expressions that should be familiar to you. You should have done this before. And describing a correlation. So correlation, line of best fit, scatter diagram. Should be a revision for you. Straightforward example. Amount of rainfall in inches, number of umbrellas sold by a shop. As the rainfall goes up, it's more likely that the shop's going to sell more umbrellas. Makes sense. This is not going to produce you a straight line if you join the points. This is where the line of best fit comes in. So we put in a line of best fit between those points. We're trying to roughly look for an even distribution either side of that line of the points that we've plotted. That's your line of best fit. That's what scatter diagrams, scatter graphs are about. We move on from there. it might be that you're actually asked to plot one for yourself. So here we've got an example of students running. They're running a 10-kilometre running race, and it's being compared with the hours that they spend playing sport. Now it makes sense that the more hours someone plays sport in general, they're likely to be fitter and able to complete their run, their 10-kilometre run, in a quicker time. The more sport that they're doing in general. Okay. Now I've plotted the first 5 points for you here to plot those other points. 47. So 9 hours spent on sport, so that's along here. 47 being the time. 12 hours spent on sport, 12 hours spent on sport, 48 minutes. Oh, that's a little bit off, isn't it? 12 hours spent on sport, 48 minutes. 7 hours spent on sport, 51 minutes. 4 hours spent on sport, 56 minutes. 3 hours spent on sport, 59 minutes. There we go. That's our distribution. Can we draw a line of best fit if we needed to? Yep. Makes sense. More hours that someone in general is playing sport, the quicker they're going to be able to complete their 10-kilometre run. Okay. That might be what you presented with. You might be presented with a little table like that. This one's math scores compared to physics scores, and you'd be expected to draw your graph using those points. So when someone scores 9 in maths, they score 10 in physics, and you can plot those 2 points on the 2 axes. And then you'll produce a load of points. You can draw your line of best fit, and you've produced your scatter diagram. Plotting a line of best fit. What are you being expected to do? You've seen me do it on the board already. We've got a set of points here on our scatter diagram. It's comparing art scores and math scores. So what we'd be expected to do, get our ruler, set our ruler against or in between our points, and draw our line of best fit as best we can. Make it as accurate as you can. Now, I was expecting you to get it exactly right. There's not an exact answer. It is an estimate, and you'll see that word a lot in the exam questions. Similarly, for the other example we've got up here, move our ruler across, line of best fit. Best we can do to try and get that even distribution of points either side of the line. Okay? Describing a correlation. Let's jump on one here. So, no, let's go back actually. No, that was good. Art and math scores. People are scoring more in art tend to be scoring less in maths called into this diagram. So we've got a negative correlation. Got a negative correlation there. We draw our line of best fit in there. Be something like that. Negative correlation, going down from left to right. This one is comparing height and the length of someone's hand. So as their height goes up, the length of their hand is likely to be longer. So this one's a positive correlation. As one increases, the other increases. This example here, which is weight and the amount of TV they've watched, there's no correlation. Yeah, there's no correlation. It's zero correlation. So negative correlation, down from left to right. Positive, up from left to right. No correlation. We can't draw a line of best fit even there, so it's zero correlation. Just to emphasise that, no correlation here, zero. Positive correlation, but quite spread out. So that's a low correlation, but it is still positive. High correlation is starting to get closer together, those points, still positive. And these, you can actually draw a straight line there, so it's a perfect correlation, a perfect positive correlation. Positive correlation, negative correlation. Curved correlation, you shouldn't really see that in examples that you're going to come across, and a partial correlation where it started off as a straight line and then it's scattered out and you can't draw a line of best fit effectively. A couple of examples then, or a few examples. Cafe. Sells ice cream, sells hot food, sells cups of tea and coffee. As the temperature increases, ice cream sales go up, positive correlation. As the temperature increases, sales of hot food, the burgers, are going down. Makes sense, negative correlation. Selling tea and coffee, I go into coffee shops a lot, and it doesn't matter whether it's hot or cold, I'm still going to buy my cup of coffee. So, zero correlation between the temperature and the amount of hot drinks that are sold. They tend to sell pretty well throughout the year. Here's a little example here. Maths and science scores being compared. What does this graph tell you about the relationship between maths and science? Positive correlation. So it's a positive correlation. As science scores go up, maths scores go up, and vice versa. Positive correlation. We could draw a line of best fit there, something like that. And when you see these type of questions, it's almost expecting you to draw that line of best fit without being asked to. And then it's asking you, if pupils scored 35 in the science test, estimate their score in the maths test. That's what we do. 35 in the science test, go out to our line of best fit, go across, and we get 35 in the maths score. So an estimate is that they'd score 35 in the maths test as well. So that's an estimate. And that's the typical type of question that you're going to be asked to complete. Another exam question here, information about each sheet. Height and the length of each sheet. So that's the length of the sheet, there's the height of the sheet. And it's plotted some of the points for you. What's it then asking you to do? It's giving you the height and the length of two more sheets. So it's giving you a sheet that's 65 tall and 100 long. So we can plot an extra point. It's asking you to plot the point. So 65 height, 100 long, so that's roughly there. 80 height, 110. 80 height, 110, so that's going to be roughly there. So it's giving you two extra points, which you get marks for plotting. Describe the relationship between the height and the length of the sheet. What is it? It's a positive correlation. As the height goes up, the length goes up. As the length goes up, the height goes up. Positive correlation is the relationship. It might ask you to make an estimate, say a sheep of a given height. How long would it be? And you just go up to your line of best fit and you'd read off the relevant value. Okay? So that is the topic in a nutshell, ladies and gents. Hopefully that's been of help to you. You will get tasks and exercises to deal with that topic. Good luck with that. Thank you very much.